Good morning, everyone. Myself Indrajit Mena. Today I am going to represent PowerPoint presentation on blockchain security. This is content. I clearly explain these contents in my next slides. A brief introduction to blockchain. What is blockchain? A blockchain is a decentralized, distributed, and oftentimes public digital ledger that is used to record transactions across many computers so that any involved record cannot be altered retro- retroactively without the alteration of all subsequent blocks. A blockchain is a type of diary or spreadsheet containing information about transactions. Definition of blockchain. From this figure, we easily understand the blockchain. Blockchain builds trust. Blockchain creates trust because it represents a shared record of the truth. Data that everyone can believe in will help power other new technologies that dramatically increase efficiency, transparency, and confidence. The blockchain network that's building a safer, smarter food supply make it easier. How blockchain works. This diagram explains us how the blockchain works. Step 1, request for transaction. Step 2, block creation for transaction. Step 3, block is broadcasted to all other nodes in network. Step 4, all not certified transaction block. Step 5, block is added to chain. Final step is transaction is executed. My main topic is started from here. Blockchain security. Is blockchain secure? Blockchain can be robust, secure, and trusted as long as the technology is executed properly. The blockchain was created to be completely immutable, so once data is put inside the blockchain, it cannot be tampered with. This means data stored within the blockchain itself is highly secure. Blockchain uses a combination of public and private keys to store and send virtual assets. What makes a blockchain secure? Four steps that secure the blockchain. The concept of mutability and consensus. In this combined immutability and consensus provide framework for data security in blockchain networks. Number 2. The role of cryptography is blockchain security. Number 3. Crypto economics. In this, it is the study of economics within blockchain protocols and possible outcomes that their design may present based on its participants' behavior. Number and finally, closing thoughts. Introducing to cryptography in blockchain security. Cryptography is the practice of developing protocols that prevent third parties from viewing private data. Modern cryptography combines the disciplines of math, computer science, physics, engineering, and more. Number 1. Encryption, encoding text into an unreadable format. Number 2. Description, reserving encryption, converting a jumbled message into its original form. And number 3. Cipher, an algorithm for performing encryption or decryption, usually a well defined set of steps that can be followed. Blockchain technology makes use of cryptography in multiple different ways for wallet, transaction, security, and privacy preserving protocols. Public key cryptography. Public key cryptography is most often used for encrypting messages between two people or two computers in a secure way. Anyone can use someone's public key to encrypt a message, but once encrypted, the only way to decrypt that message is by using the corresponding private key. The diagram explains about the public key cryptography. Public key and private key cryptography. Public key cryptography is a fundamental element of blockchain technology. It is the underlying technology for wallets and transactions. When a user creates a wallet on a blockchain, they are generating a public private key pair. The private key associated with a wallet is how to prove ownership and control the wallet. It is the only way to send coins, out of it, and a lost private key means the coins inside will be stuck there forever. Cryptography hashing. Cryptographic hashing is another fundamental piece of blockchain technology and is directly responsible for producing immutability, one of blockchain's most important features. Cryptography has functions that have these crucial properties. Number one, deterministic. No matter how many times you give the function a specific input, it will always have the same output. Number two, irreversible. It is impossible to determine an input from the output of the function. Number 3. Collision resistance. No two inputs can ever have the same output. Simplified Bitcoin blockchain. Here three block transactions. Number one, block one transaction. Block one header has of previous block header Merkle root sends data to block 2 transaction. Block 2 header has of previous block header Merkle root and sends it to this send to block 3 transaction. Block 3 header has of previous block header Merkle root. This is the architecture of cryptocurrency. Why do people want cryptocurrencies? Eliminate the for a central bank third party. Want to be anonymous, pseudo anonymous, trade it like it is a stock using exchange like a stock market. A way to transfer wealth, grow wealth, speculation. Raise funds for a project ICO. Faster global payment mechanism with no currency conversion. Blockchain security level, or we can say it's application of blockchain security. Many questions are raised in the blockchain security, such type of on transactions such as are transactions validated with certainly accounts, are user accounts secure, programming, are contracts performing with intended accuracy, distributed organization, are sound operational practices at the base of the implementation. Network is the risk of a 51% attack will well mitigated. Governance is decision making well defined and representative of the stakeholders. Thank you.